Our life, our life. Let's see. We're alive. We're alive, though. We're alive. Okay, let's go. Part two. Part two. Part two. Okay, let's go. Okay, okay. Let's go. Um, Qualitative features. Age. Something like age is another thing, is another kind of qualitative kind of qualitative feature. Okay. Yeah. No, not something like age. If you take something like group of age, like baby, baby, like baby kid, adult, Gen Z, boomer, etc. We if we take these different categories, it can be um, it can seen as qualitative data set. Okay, because you can assign one of these categories to somebody, and it doesn't necessarily necessarily. Okay, map to a specific number. Okay, original data. Okay, so there is qualitative data and there is ordinal data. Okay, what it is? What is original data? No, yeah. Might be a rating system from bad to good. So the difference between qualitative data and original data is that original data has an order. So the difference between qualitative qualitative data and original data is that um, qualitative data, the original data has an order. Okay, in order to code this into a number, we might just use a system like 1, 2, 3, 4, 5. So it means qualitative data does not need one hot encoding. But if you remind yourself, one hot encoding, one hot encoding, what is one hot encoding? This for qualitative data. So original data does not need one hot encoding. So qualitative data, you transform your data like that into a 0 and 1, and that's how you do it. But for ordinal data, you can, because it has a value, there is another, because better than good is better than bad. So you can and bad is better than mediocre. You can rate mediocre as 0, bad as 1, and good as 3, and excellent as 5. Qualitative data does not need hot encoding. We can give it a number like 1, 2, 3, 5. 1, 2, 3, 4, 5. Save. Does it work? I don't know how to reference this thing. Can you reference? How do you reference a chapter in Google Documents? How to reference a chapter in Google Documents? How do you reference sections? Tools, under text, click insert link. Under text, enter the text you want to be linked. Okay, let's try that. Insert link. Okay. Text. One hot again. Okay, Nick. Okay, I get it. Makes sense. Makes sense. Okay, let's go. Why we can use it's a super course, because it answers my questions immediately after I ask them. Why we can use one hot encoding. One hot for nationalities, but we can use 1, 2, 3, 4, 5 other. Our computer. Okay. Yes, right there. Boom. And make a new section. We can use different nationalities. Oh yes, fuck. We can use ordinal data. Original data is because a computer knows that 2 is closer to 1 than 5. In a case like this, makes because 2 is slightly less worse. It's warm here. It's kind of warm here, bro. Two is less worse than one. And five is here. But in our nationality example, it doesn't make sense. Rate USA 1, India 2, France 3, etc. Still explaining why we also have quantitative features. So qualitative, quantitative, and what already? Qualitative, ordinal, and quantitative. Okay, get it. Quantitative function. We also have the numerical, numerical value that can be described as continuous. Okay, numerical values values are data values. Numerical values are data values that can be discrete or continuous. Okay, what can it be? So, quantitative data, qualitative data. Oh, I, I forget this one. Quantitative, qualitative, and which one already? Ordinal. Ordinal, quantitative, qualitative. Get it. Ordinal, ordinal, ordinal value, quantitative value, qualitative value. Okay, get it? Get it? Quantitative are numerical values. Okay, quantitative values are numerical values that can be discrete or continuous. Okay, it's okay. So, quantitative value, qualitative value, ordinal value. I get it. I got all of them. Okay, okay, okay. Get it. If you measure the size of your desk It's quantitative. So if you measure the size of your desk, it's quantitative value. If you measure the temperature of the fire, mm, the fire, it's quantitative value. Okay. If you count eggs, if you count eggs, it's quantitative. Quantitative. Hmm. It's a quantitative value. Yeah. Yeah. It can either be discrete or continuous. For the eggs, for example, you never really say like you have 7.1 eggs. You say I have 7 eggs, and that's all. Okay, okay, I get it. So let's summarize. There is ordinal value. There is quantitative. There is qualitative. Qualitative is like there is no inherent order. It's like the countries, like you cannot place one to France, two to India, etc. Ordinal value. There is another like mediocre, bad, good, excellent. You can say one, two, three, four to rate all of them. And quantitative is like the height, like how much do you what's your height, what's your weight. That can either be discrete or continuous, and that's all. Okay, I get it. I get it. Get it. Okay. X, X, for example, are discrete continuous values because they are finite. You don't say I have 7.1 eggs. You say I have 7 eggs, and that's all. Okay, continue that. Okay, we even have the example for us. Right? Okay, those are the different type of inputs that we might be able to feed our model. Okay, those at the left are the different types of input we might be able to feed our model. The left. What about the different type of predictions that we can actually? Okay, 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 okay. What about the different types of prediction that we can actually make with our models? Okay, it can be a chapter in itself with our models. Let's look at the outputs. Like clearly, we're gonna look at the outputs. Look at the outputs. Okay, it will be the outputs. Boom, boom. Outputs predictions. So we have seen the inputs. We have seen there is quantitative data. That can be either discrete or continuous. Can be the height or the number of eggs you have. You have seen there is ordinal data. That is data that is inherently that inherently have an order, like bad, good, bad, good, mediocre, excellent, etc. You can put 1, 2, 3, 4, etc. And there is quantitative, and there is qualitative. And in qualitative, it's like gender, the number of the name of a country, and there is no order in it. So you don't give. So you have to use one hot encoding to encode this kind of data to make sense for the computer. So now that we have seen all that, we will see the outputs. There are a few different tasks that we have in supervised learning. Okay, what what are she talking about? Okay, well, that we have in supervised learning. Okay, okay, let's list some tasks in supervised learning. Okay, there are a few different tasks that we have in supervised learning. We have classification. Classification, I mean, I think classification. What is classification? We can ask ChatGPT. What is classification in machine learning? I, I, okay. It doesn't work. Perfect. Okay, classification. I can directly be like, whoa, boom, boom, classification. Um, okay. What is classification in machine learning? Which means we are predicting discrete classes, which means that we are predicting discrete classes. So in machine learning, when you do classification, you predict discrete classes. I guess you are predicting classes based on this thing here, where you have your data and you have directly the label associated with the data. So I guess it's like that. We'll see what ChatGPT says about that. Classification in machine learning is a process of organizing data into predefined categories or classes. The model is trained on a labeled data set. Okay, it's that. It is a labeled data set. You have the data and you have the label. Okay, so what is classification in machine learning? Okay, classification in machine learning is a process of organizing data into predefined categories or classes. The model is trained on a labeled dataset, where the input features are used to predict the class or category of the output. Okay, the model is trained on a labeled dataset. Okay, classification in machine learning is a process organizing data into predefined categories or classes. Categories or classes. So, so in classification, you need to have predefined categories or classes. I think predefined by the programmer. So in classification, you need to have predefined categories or classes. Okay, that's the axiom. The model is trained on a labeled data set, like this one. It's perfect. The model is trained on a labeled labeled data set like this one, like the one below. Okay. This is a labeled data set where the input features are used to predict the class or category of the output. Okay. The model is trained on a labeled data set like this one below, where the input feature, okay, where the input features, okay, input features. Do we have input features? Input features. Where the input features? Input. Okay, we can go to features. Okay, where the input features. Okay, where the input features, and we okay, input features is things like this. Input features, things like this. Okay, input features are things like this, and they are vector input. We can say. I don't know if I think they are vector. Where the input features, things like this. Okay, where the input features are used to predict the class or category of the output. Okay. Input features like this are used to predict the class or category of the output. Okay. They are used for that. And then, so you put input features, and then they give a class. Okay. Or a category. So basically, you give input features. Input features can come in 3 categories, at least that are listed in this course. Okay, so basically you give input features, and the computer give you a class. Okay, so basically input features can come in 3 different categories, at least listed in this course. So different categories are okay. Remind yourself the different categories of input feature. Yourself the different categories of input features, and like we have done, insertion, link, qualitative feature, oh shit, qualitative feature. Okay. Insertion, link, quantitative. Sure. Okay, perfect. And ordinal feature. That's that. Insertion, ordinal. Okay, I get it. And you can see it. Okay. Okay, are we there? The goal is to learn the underlying relationship. The goal of the computer, because it's the computer who is learning. The goal of the computer is to learn the underlying relationships between the input features and the output classes. So you give the computer the input, you train the model to learn the relationships between the input and the output. He figures this out, and then when you give him some input, he can give you a prediction, a class, so that the model can accurately accurately classify new unseen data. Common example of classification. Okay, common example of classification model slash classification task. Classification tasks. Tasks. Okay, common example here. Image recognition, spam detection, natural language. Natural language processing is not really a task, because what if I type Google, what is natural language processing? It's not a task in itself. It's a subfield of computer science and artificial intelligence to understand, okay, um, understand and process human language such as English. So understand human language, I would say. It's better suited. Understand human language. The task of understanding human language in NLP. Okay. The thing I want though, I want an example of a feature. I want an example of a feature because I want an example of an input feature here. So I will go to u.com. Please give me an example of an input feature in machine learning. Please give me an example of a machine of an input feature in machine learning. Please. An example of an input feature in machine learning is the age of a customer. Okay. Where the input feature are used to. Okay. Example of an input feature of machine learning. Okay, it's perfect because I would put it there. Example of a machine feature in what I'm saying of an input feature in machine learning. Okay, I get there. Okay, I can be like so basically you give it input feature, reminder of what is an input feature, like this. I can go like boom, link, reminder of what is an input feature. Input feature. Example of what? Okay. Okay. Boom. An example of an input feature in machine learning is the age of a customer. Age can be used to predict the customer's likelihood of purchasing a product or using a service. The input feature could be a numerical value such as the customer age in year, or a categorical value such as young adult or elderly. Interesting. I can even reference this. Okay. Categorical. Okay. CF, categorical value. Boom. Insert a link. Categorical. Categorical. Qualitative. Qualitative data. Is qualitative data and quality I'm asking a question. Is categorical value and qualitative value the same? And qualitative value the same in machine learning? Because it looks like it's the same. In Okay. In machine learning, categorical values and qualitative values are often used interchangeably and refer to the same thing. Okay, I will make another. I will make another chapter, and then something. Um, Qualitative value and categorical value are the same in machine learning. Quali- Qualitative value and um, categorical value are the same in machine learning. Get it? Boom. In machine learning, categorical value and qualitative values are often used interchangeably and refer to the same thing. Let's go, let's go, let's go. Okay, okay, okay. Um, okay. I will put it there. Okay, in machine learning, categorical values and qualitative values are often used interchangeably and refer to the same thing. Both terms refer to non-numerical data such as text or labels that are used to represent different categories or classes. Categorical variables are variables that can be divided into categories. They can take on a limited number of values such as red, green, blue, true, false. Qualitative variables are variables that describe a characteristic or attribute. Okay, or attribute of an object rather than numerical value. Yes, they can be used interchangeably. Okay. Okay, I get it. I get it. Okay. Okay. Boom. Boom. Um, Categorical value. And I will just refer to this here. Categorical value are the same. No. Intention. Categorical value. Yes. Qualitative. Okay. So perfect. It's perfect. Okay, I think to be fair, I've explored more what is classification than I think she will explore it. I think I've really explored each word of what is classification. But let's go. Example. Example of classification. Another example of classification. Example have a picture of picture. Okay. For example, we have a bunch pictures of we have a hot dog, a pizza, and ice cream. Picture of food. There we have a hot dog, pizza, and ice cream. Okay, get it. Okay. The dot gets mapped and not dot label. The pizza gets mapped to a pizza level. The ice cream gets mapped to the ice cream label. Simple. And if we have any additional photo with one of these, we want to map them to one of these three classes. Okay. Okay. Multi-class classification. Interesting. Multi-class classification. Okay. This is known as multi-class classification because we have a bunch of different classes. That's what we're trying to map into. We, okay. Okay. Another kind of model of classification. Okay. What if instead of that ice cream, we have another model that's called us. Okay. What if instead of hot dog pickles and ice cream, we have another model, whether or not something is a hot dog? Oh, what is this ad? Seriously, what is this ad, bro? This ad doesn't even make sense. Okay. On the left, it's a hot dog, and on the right, it's not hot dog. Okay, okay. Binary classification. That's how we call it. Binary classification. Okay, binary classification because there is only two binary classification because there is only two classes. Okay, I can directly open myself a new chapter. I can say what the difference between binary classification and multi-class classification. The difference between binary classification and multi-class multi what? Yes, multi-class. Multi what? Yes, multi what? Multi-class. Multi-class, sir. Multi what? Multi-class classification. Yes, yes, sir. Yes, yes, sir. Yes. The difference between binary classification and multi-class classification. Okay. The difference between binary classification and multi-class classification is that in binary classification there is only two classes. In in multi-class classification there is more than two classes. I would say that like that. The difference between binary classification and multi-class classification is that in binary classification there is only two classes, but in multi-class classification there is more than two classes. Okay, I will ask ChatGPT what is the difference between binary classification and multi-class classification. What is the difference between binary classification and multi-class classification? In binary classification, the goal is to classify data into two predefined classes or categories. For example, classifying an email as either spam or not spam, or identifying a tumor as either malignant or benign. In multi-class classification, the goal is to classify data into one of more than two predefined classes or categories. For example, classifying images of unwritten digits as one of the digits 09, or classifying news article into one of several. Okay, okay, I get it. So I had it right. So that's the principle. I had it right. Okay, but there is a more advanced explanation from ChatGPT. In binary classification, the goal is to classify data into one or two predefined classes or categories. It's it's better written than than me, but me it's my words, so I understand it better. The difference between is that there is only to classify data into one. Okay, uh, there's one or two classes. One or two classes. For example, classifying an email as either spam or not spam, or identifying a tumor as either malignant or benign. In multi-class classification, the goal is to classify data into one or more than two In multi-class classification, the goal is to classify the data into one of more than two. Okay, there is more than two predefined classes or categories. Okay, so I can say I can paste it here, and then here we can find that ChatGPT offers us some information about the model architecture. So what the model architecture of binary classification versus multi-class classification. In terms of the model architecture, binary classification models typically only require one output layer with two neurons. In terms of the model architecture, binary classification models typically only require one output layer with two neurons. Okay, so let's, you know what? Let's go directly into Canva. Let's go directly into Canva. We can be like that. Okay. In terms of the model architecture, but binary classification model require only one output layer with two neurons. Okay, we can be like that. Binary classification. Boom. Okay. Boom. Wait. Oh, wait. Binary classification. We can do that. We have two neurons. Okay, let's go into Canva. Okay, let's go. We create a design. Thing like that. Boom. No, not a thing like that. Not a thing like that at all. At all. Okay. Boom. Boom. Okay. In terms of the model architecture, binary classification models typically only require one output layer with two neurons. Okay, one output layer. I can be like boom, boom. Output layer. We can have one. Yeah. Output layer. So I can directly say boom, boom. No, I need something black. I need black. Something, something badass. I don't know. Yes, not like that. Okay. Model architecture of binary classification. Let's see. Okay, boom. Can put it there. Okay, one output layer and two neurons. Oh, I can ask something. I can ask something to. I can first, because right now I'm doing a technical drawing. Basically, I'm basically doing a technical drawing to mimic the architecture of a binary classification model. Basically, I can do it like okay. I'm basically doing that, so I can see if does it already exist. I can make an arrow here. I want a bigger arrow. I want a big arrow. Turn it to black. Oh, I cannot. Oh, I cannot. Arrow. Arrow. Boom. Came. On this one. Turn it to black. Here, it will be the inputs. Basically, it can be directly the like they said feature input. So in here, I can take the same input one like that, input one, input two, etc. And then we'll search on Google how bad is my drawing or how good it is, because it's a highly it's all is intuitive here. I've never seen how they represent it, so it's really intuitive. Input, uh, boom, okay, boom. Model architecture of binary classification, boom. Okay, okay, done. Can I have a model architecture of binary classification? Okay, it, it doesn't look like me, like mine. But I don't know if there is the right architecture though. I don't see the okay, the description that ChatGPT made of a binary model. Let's see. Let's figure this out. Okay, binary. Okay, architecture of binary classification. I just want one. I just want one. Okay. I don't know if it's the right architecture though, because I don't see the 1, 2. Is it binary? No. Two-step supervised learning. No, it's not what I'm looking for. Oh, maybe this. Malware dataset Benin dataset. No, I think I have the most accurate representation of a binary classification architecture of the whole internet. That's what I think. The architecture of binary classification. I don't see anyone else who has a better thing. Oh, maybe here. So it's like that. Maybe it's that. So there is an input layer. So input, I think it might be that, and there is two layers. Okay, and this is the output layer. Okay, so I must represent that like that. Is it like that? I don't know. I will copy that and figure this out later. Um, version. I will be like that. Version made by me, and version from on Google. Google. Okay. Okay, let's finish that though, because I was there. Multi-class classification. Boom. Multi-class classification models typically require an output layer with as many neurons as the number of classes. Okay. The number of neurons is that. Well, the number of neurons in the output layer corresponds to the number of classes we want to predict. Okay. Let's dive into multi-class classification architecture. Give me some architecture, man. I want some architecture, man. Okay, it might be okay. So here we can see there's multiple output layers. Here, hidden layers. I don't know why there's not the same number of hidden layer for both. I think, I don't know. You correct me. I think this is class one, this is class two, etc. And the output, there is as many layer. Um, okay, the number of neurons in the output. So okay, here, because there are three neurons here, I think this is our neurons. Because there are three neurons here, so there is only three classes to figure out. I think. I don't know. Correct me on this one. Tell me what I have right, what I have wrong on this one. Let's copy paste this though. Let's copy paste this though. Okay. Another way to think about the difference between binary classification and multi-class classification is that binary classification is special case, multi-class classification with only two classes. Difference between binary classification. Okay. Let's go, let's go, let's go, let's go, let's go. Damn, it takes time to study. It takes time to study this. I hope I finish this one, this tutorial today. So tomorrow I plan something. I plan something good tomorrow. That's one. Other example. An example of the difference in classification. Okay, here she is trying to say to us which are the type, which how can we differentiate between um, binary classification and multi-class classification, and she gives us a ton of example here, and then I would just copy paste. To be honest, because I think we have explained more than she will the difference between binary classification and multi-class classification. All that thanks to Class GPT, to ChatGPT, who didn't exist, who who was not as big as it was today, 7 months ago when she made that video. Let's go. Okay, different types of fruits, different types of plants, different type of classes. That is multi-class classification. Okay, regression. So we talked about classification. Okay, maybe classification should be like a big topic, because I really think about how I structure all that. I structure my notes to really make it clear when I would come back to them. So maybe classification is like a whole chapter, a subchapter in outputs. Okay, classification. Boom. I will just do that. Boom, and then I will put all that in that category. Boom, boom. And then we'll do regression. Chat. What is the difference between classification and regression? Let's figure this out. If you have not, if you don't know the topic of machine learning, I'm learning in the same at the same rate as you. So we are both in this together. Um, so I don't know the difference between the classification and regression as well. Oh, I might have an idea. I think it's like um, classification. Ah, yes, they said it. Classification. You try to predict a class, and like a class like a dog, a dog, a cat, a pizza, a dog, etc. But in regression, you try to predict continuous value like the price of a house, the price of a car, the height, etc., etc. I think it's that. Is that. But in all that, there is not. So you learn classification, you learn regression, and things like open AI, like the awesome intelligence artificial we have here, like ChatGPT. Here is another kind of AI. It's more like a generative AI. To be honest, it's really exciting. It's a really exciting kind of technology. There is oh, there is also something named regression, and what regression does to predict image value. For example, left bottom, this is the price of Ethereum, and we want to predict where the price will be tomorrow. Okay? Mm, okay. It's different values we can predict for that, and don't necessarily fall. Okay. 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 What it means, like continuous values, it means it's just a number, and it can be so many different numbers. So that's why we cannot give it a class. We just can give it. It's another kind of problem to solve. It's you cannot solve the height of a dog in talking about his his. You can, but it's solve a different problem because when I think about it, you can say a dog of 1 meter is like a mini dinosaur. A dog of 2 meter is like big dinosaur, etc. So you can classify this, but regression is um, trying to solve another kind of problems. That's all. We can predict. We can predict for and class. Class doesn't make sense. That makes sense. In that case, um, we are looking in that case for a continuous number, and that is an example of regression. Okay, or it might be okay. I can already divide it in. Okay, example. Example for the price of Ethereum, for example. Boom. Example for the temperature of tomorrow. Picture. The temperature of tomorrow is another example of regression. Trying to predict the temperature of tomorrow. Trying to predict the temperature of tomorrow is another. Okay. Okay. Example of regression when trying to predict of regression when trying to predict the temperature of tomorrow. Of regression when trying to predict. Okay. Regression is trying to predict. That's what I think. Give it values of you give it values of that you have about the market, about what is happening, and then regression will try to predict what will happen. That's how how I see it. Okay, I will note it there. Regression is when you give it data of what is happening, and then it will predict, it will try to predict that way, as try to predict what will happen based on the data you feed him. Temperature of tomorrow is another example of regression. Okay. Okay. Example of regression. Um, when trying to predict the value of a house, trying to predict the value of an house. Okay. Okay. Trace. Okay. It might be what is the value. It might be what is the value of this house given how many first house it has, many garages, many garage has. What's the zip code? Okay, let's go. Let's go. Let's go. Now that we have talked about the input and output, okay, output, output. We're getting somewhere, guys. We're getting somewhere. We are getting no. It's not output there. It's anatomy of the data set. Anatomy of a data set. Okay, let's go. Let's go, guys. Let's go. Let's go. Let's go. Okay. Now that we have talked about the input and that we have talked about the output, okay. Is it me or she has said the same thing twice? She said the same thing. Now that we have talked about our input and that we have talked about our output, that is pretty much machine learning in a nutshell, except for our model. Okay, let's talk about the model. Let's talk about the model, guys. Let's talk about the model. No. So, are we really going to talk about the model? Because the title of the section, the entire section is anatomy of a data set. So I don't see model in there. I don't see any any mention of a model in there. But let's you know let's trust them. Let's trust the process. You know what? Let's trust the process, bro. Let's trust it. Okay. Okay. For a specific model, let's discuss How do we make the model learn? And how can we tell whether or not it's learning? Oh, it's really good. Um, you know what? What I will do is like make a new title and build like that. How to know, how to um, make the model learn in machine learning. And of course, I will ask ChatGPT. Of course, like, of course, I will ask ChatGPT, bro. How to make the model learn in machine learning, and how to know if the model is learning or not in machine learning. And of course, before even listening to her, what we will do is ask Chat GPT, bro. Of course, bro. How can we tell? I would be like that. And how can we tell whether or not it's learning? Okay, let's go. Let's go. Okay, how to make the model learn in machine learning? We'll just like copy that, say hello to ChatGPT, and just paste it, bro. Tell me, ChatGPT. Tell me, quick. Tell me. I don't have time, ChatGPT. Tell me how to make a model learn in machine learning. In machine learning, the process of making a model learn is called training. Okay, you train your model. Uh, you train your model. Hey, in machine learning, the process of making a model learn is called training. The model is trained on a labeled data set where the input features are used to predict the output of a class. So it's talking about classification because what it's saying, the model is trained on labeled data set where the input feature are used to predict the output of class. Oh, it can talk also about regression because regression, there's no class, but it's a continuous value. The goal is to learn the underlying relationship between the input features and the output so that the model can accurately predict new and seen data. There are several steps. Oh, he's listing the steps. He's listing the step, bro. He's listing the steps that we have to take to train the model. One, collect and prepare the data. The first step is to collect and prepare the data that will be used to train the model. This includes cleaning, normalizing, and formatting the data so that it can be used by the model. Split the data. Next, the data is typically split into a training set and a test set. Okay. First, okay, we collect the data, then we split the data, then we define the model architecture. Okay, I get it. So, okay. Nice. ChatGPT is so useful. ChatGPT is a cheat code, bro. It's clearly a cheat code. Now I can see through the matrix, thanks to ChatGPT, bro. Okay, let's go. We paste it, bro. Okay, one, one, two, three, four, five, six. Okay, that's good. That's really good. This is really good, guys. We're going somewhere there. We are going somewhere. It's worth noting that the process of making a model learn is an iterative process, and the model must require several rounds of training and fine tuning before it performs well on new unseen data. Hey, hey, hey. Okay, okay. How to know if the model is learning or not in machine learning? Okay, to train the model, collect them, the collect the data, split the data, define the model architecture, train the model, evaluate the model, fine tune the model. 6 step. Okay, 6 step. Collect the data, split the data, create the model architecture, train the model, evaluate the model, fine tune the model. Okay, collect the data, split the data, create the model architecture, train the model, fine tune the model, evaluate the model, fine tune the. Okay, collect the data, collect the data, split the data, create your model architecture, train the model, evaluate the model, fine tune the model. Okay, I get it. I get it. I get it, bro. I've learned more today about machine learning than my entire life. I think about machine learning. Okay, let's go. How to know if the model is learning or not in machine learning? In machine learning, there are several ways to determine if a model is learning. Okay, let's go. Okay, okay. Hmm. Monitoring the training process. One way to determine if a model is learning is to monitor its performance during the training process. This can be done by plotting the model performance. One way to determine if a model is this can be done by plotting the model's performance on the training and test set as a function. Okay. Mm, one of the ways to determine if a model is learning is to evaluate the performance. You know what? I have no way of understanding all that. I can ask ChatGPT, but let's listen to what the teacher has to say about this. Let's go. Okay, let's go. Okay, what this represents? A data set. Uh, an example with a data set. 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 Okay, let's go. Boom. Anatomy of the data set. Okay. Okay, let's go. An example with a data set. Okay. This uh, workflow of people, and the outcome is whether or not they have diabetes. From certain group of people. Okay, so basically, if we go back to the example of classification, it might just be like the data set might be just like the cat, like we see that there, and the outcome might be like just the label, you know. That's all. Okay, makes me think about. Yes, makes me think. Um, ah, okay, okay. This make me think about that. The data set um, in this example. In this example, the cat is the data set. The cat picture is the data set, and the label is the outcome. That in the data set, this data set is representing whether or not the patient has diabetes, 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 diabetes or not. Diabetes or nah, or nah. I can say like I can say it like that, bro. I can also say it like that. Do they have diabetes or not? Let's go. Okay. The outcome here. Outcome here is whether or not they have diabetes, and hold the outcome here. Let's let's straight it up. Let's make it straight, bruh. Like the outcome here, and I screenshot the outcome. I put it there, and the matrix here is whether or not is here. How many pregnancies they have? What is the glucose number? Glucose they have had. What is the glucose number? Like what the blood pressure is like? Okay, let's screenshot this also. We can see that all of this. Okay, we these are actually quantitative variables. They might be discrete or continuous. Okay, we can see here there is no need to do one hot encoding or transform the data here into another kind of data because all of these are quantitative variables. At least that's what I understand. Bit or continuous, but they are quantitative. Each row in the data set represents another okay. Each row in the data set represents a different sample in the data. this means each row represents a different person. Okay, each row represents one person in our data set. In our data set. Okay. Yeah, I get it. Clear, it's clear. It's clear. I get it. Get it. Okay. Now each column is a different feature that is in our data. Okay. Each row represents a new person in our data set, and each column represents a new an no, each column is a different feature. Uh, Okay. Each row represents a different column. Uh, each row represents a different person, and each column represents a different feature. Simple. French. It's French. Oh, in French, we say "pas français." Like, you know, say it straight up, bro. Say it straight, you know. Okay. Each column is a different feature that we can feed in our dataset, except for the outcome column. Except for the outcome column that is um, the output label. Okay, straight up, we understand that. Okay, it's the output level that we want our model to be able to recognize. Okay, straight up, we understand that. This is what we call a feature vector. Okay, so each person. Okay, no, it's not each person in the column in the row because we can see they have not selected the outcome column. So the feature vector is just a list of features. It is just a vector composed of a list of features. Feature vector. Okay. You know what? I will make it more clear. I will make it more clear. Row. Okay. I'll put there row. Boom, boom. Column. Boom, boom. Feature vector. Boom. Outcome. Yes, baby. Yes, baby. It's clear. It's clear as freaking clear. Boom. Trying to figure this out. It's perfect. Perfect. Feature color vector. This is what is called a feature vector. And you can, I will write some notes on that. So when I reread it, it's clear as water. You know? Okay. Okay. This is what we call a feature vector. This is what we call a feature vector. Okay. And we can see we have not selected the outcome column. Indeed. 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 That is the column we are trying to predict. Okay. I make a pause in 2 minutes though. The target for the feature vector. Target for the feature. Okay, let's go. This is the target. This is the target for the feature. Boom. This is we are trying to predict. Okay. She's throwing a lot of vocabularies at us right now. I'm trying to catch them all and really summarize this in my notes. Okay. All of the data, feature matrix. All the data together is known as the feature matrix. Okay. Done. Okay. Label slash. Okay. Let's go. All these outcomes together, we call that labels slash target vectors. Okay. I get it now. This is a feature vector. One row of selected feature is a feature vector. One instance of an outcome is no target for the feature vector. The whole data without the outcome is a feature matrix, and the whole data for the outcome is the target vector. Target vector. Okay, get it. Oh shit. Let's make a pause. I will come back in like 10 minutes. See ya.